Hi, I'm Alex Bayless. I'm an engineer here at Agilent Technologies. And today, I'd like to bring up an issue that we've seen from customers, and that is a lot of them can't get direct control over their Ethernet controller. And I'm going to show you how to resolve this issue. We can use our 9000 oscilloscope along with our Ethernet application, and we can get a nice consistent link pulse. And this is exactly what we're looking for when we want to run the Ethernet app. So in our setup today, we're going to set up this DUT so that it can send out a consistent link pulse. And we're going to do that within the XP Windows environment. Down here on our fixture, we're going to connect a link partner to it so that we can have a consistent pulse. And over here on a scope, we're going to reconfigure it also with its Ethernet controller so that it's sending a consistent 10 base T link pulse. This is our Agilent test fixture. This comes with the Agilent Ethernet test application. We have our DUT on this side connected to our Ethernet cable, which is connected to the DUT side of this Ethernet connection. Also, we have the probe connected to our 9000 oscilloscope, and we want to make sure our polarity is correct on the probe versus our test point. And that's our setup that we're starting with. So as you can see, this customer's DUT is very inconsistent. The pulse is coming and going in an irrational fashion. It should be 16 millisecond pulses. And his DUT is trying to negotiate different link speeds. So this is where our issue is, and I'll show you how we correct this problem in our next setup. Here we are on the customer's DUT, and we're actually in Device Manager. We're going to go to our network adapters and click on the DUT itself, the Ethernet controller. We want to select Properties and go to Advanced. We want to select Speed and Duplex. I want to change this from auto negotiation and force it to 10 megabits full duplex. Make sure we click OK, and that's our setup for our DUT. We would also do this on the oscilloscope, and it's the same exact setup. Now that we have both our oscilloscope and our DUT set up, we're forcing it to do 10 megabits per second. We want to connect our link partner, which in this case would be our oscilloscope, to the fixture. And we can see also on the DUT here that we have a consistent link. So here we are on our 9000 oscilloscope. And as you can see, we have a nice consistent link pulse now. The link pulse is now 16 milliseconds, which is what we want to look for. And so now we can run our tests. I'll bring up the Ethernet compliance application, and we're going to simply select the 10 base T tests. And in this particular case, we are running the link test pulse with twisted pair model. This will actually show us the setup and configuration that we need to set up on our Ethernet test board. Shows us also connections that we need to make and the jumpers that we need to set up. And also it gives us a great picture of our signal that we're looking for. Once we have this all completed, we can run our tests. As this runs, you can see it running through the compliance application tests with all the templates for this particular test. Once we've ran through our tests, you'll notice that in the results tab here, we can see the test has passed. We can actually see the HTML report. It gives us a nice status of our pass status. And it also shows us the details of the report as far as our mass tests and pictures relevant to those tests. And that's how we resolve our Ethernet application link pulse issue. So in this video, we showed you where we had an issue with a customer DUT with an inconsistent link pulse. We also showed you how to set up the oscilloscope as a link partner so that we could run our Ethernet application. Please check out our website below, and thank you for watching this video.